All right, so on page 574, what we're going to do first is we're going to do number 21, part C first. And on 21, part C, when I find where I set my book down. On 21, part C, whoops, wrong side. It said find the areas for each normal distribution using the given information. So for 21, your mean was 12 and your standard deviation was 1.5. Now we have a formula that we were using for these when we are trying to find our area below, which deals with using our z-scores. Okay, so our formula that we use, remember, is z is equal to x minus the mu, and then divided by the standard deviation. Is that right? Yeah. Okay, I want to make sure I didn't get them backwards. So it's x minus the mu, the average, divided by the standard deviation. So that's the formula we keep using in these. So looking at number 21, part C, on page 574, this is kind of where we left off on Friday. We've got to find the area below. It always talks about like the area below each thing. So we're going to find the area below the curve at when x is 11 and when x is 14. Okay, because then it's going to want the difference in between there. Now, if you pay attention, we had already done the area below 11 and then the area above 14 in part A and part B. But we'll go through and do them again just so you have some more practice. Okay, so we're plugging them into the formula. So I have z equals x minus the mu, which it told you at the top of the problem, the mu, the average was 12, over the standard deviation, the sigma, which was 1.25. Okay, so that's my first one, and then my second one will be the exact same thing, except instead of 11, I'm going to have 14. Okay, so we work both of those out first. So hopefully you all know 11 minus 12 is -1, divided by 1.25 gives us a decimal, -0.8. And then hopefully you know 14 minus 12 is 2, divided by 1.25 gives us a decimal of 1.6. So these answers should look familiar because we had this in part of our answer for part A and part B. Now, from here, these are what we call our scores that are on our table. Remember, you have that big table in your book. I think it's page 567 that we kept using for all these. Page 567. Remember, the number that's in front of the decimal is on the left-hand side of the column. The number that's after the decimal is going across the top of the column. And then where they meet is the number for this. So I need to get my table. Page 567. On our big table here, we have -0 on the left-hand side and then 0.8 across the top. And I get 0.212 for that one, if I did it correctly. And then the other one was 1.6, so I go to 1 on the side. And then over to 0.6, and that's at 0.945. Okay. Now, for part C, the area, sorry, my throat's like, okay. When I want to know the area below, I found both of these, okay? But it doesn't want just the area below on this one. It says the area what? Between them. So if I'm doing the area between them, I've got to do what with those two answers?
Subtract.
Add them, subtract them. What do you think?
Subtract.
Subtract them, right? So I'm going to subtract these two numbers. Now, when you're subtracting these, your answer for this is going to be a positive. So you put the biggest number first when you're subtracting. So which one of these numbers is going to go first, 0.212 or 0.945?
0.945.
You take 0.945 minus 0.212, and we get another decimal,
733.
okay? So that is our area between, which is what I wanted on part C, okay? Everybody good with that? Yes? All right, now, part A is just doing one of those, part B is just doing one, part C is like, on 22 is like part C we just did up there. So we use our formula first to find our z-score, and then we use that to get the number from the table, and then that's what we're using. So let's see, for 22, on 22, it told you your mu, your average, was 110. And then it told you your sigma, your standard deviation, was 6.2. So these are our numbers that we're going to use with our single x values to find our area below or area above or between, whichever one is asking for. Okay, so on 22A, you were supposed to have hopefully tried this one on your own on Friday, but you start off, remember, this is our formula that we're using. So I have z equals the x, 115, minus the mean, 110, over the standard deviation, which is 6.2. So you take that, you divide it, you get a decimal of big long number that goes forever, right? Y'all agree with that? Did you get a big long number that goes forever?
Yeah.
If you did it, you should. Now you'll notice though, when we're talking about our z-scores, they're always rounded off to the nearest what place?
10th.
10th, one decimal place, right? So if I'm going to take this big thing, is 0 going to change the 8 in the front?
No.
So it's just going to be 0.8, okay? So this is 0.8, and now you use your table. So 0.8, okay? Everybody there?
Yeah.
We got 0.8, what is it?
0.788.
0.788, okay? So the area below is 0.788, that's all you gotta do. Because the area that you find from that table is below, okay? When it's talking about above, then that's when we'll have to do an extra step. And Ellie, we're going over those problems you were supposed to have tried at the end of class on Friday, 21 and 22 from page 574. Okay, that's where we're at. Now, for part B, it says above, but we still start the same way. So you're still going to start with your z equals your x value minus your mean over your standard deviation. So you're going to have 122 minus 110. And then divide that by the 6.2, and you'll get a decimal that goes like forever. Everybody see the big long decimal? Goes all the way. Remember we said we round to the nearest 10th, so is the 3 going to make that 9 go up?
No.
No. So it's going to be what?
1.9.
Okay. So that's 1.9. So we look at 1.9 on our table. 1 is here, 0.9's all the way over here. So I got 0.971.
Yeah.
Now, remember, that's the area below. But what did it actually ask us for on this one?
Area above.
So when we do that, we have to subtract this from what number?
1.
1. So you're going to take 1 minus 0.971 and get
0.029.
So that's your answer for part B. Okay. Now for part C, it's similar to what we did on part C on number 21 at the beginning. We still do the Z formula for both of them. So I had my first Z is when X is 102. So I have Z equals 102 minus 110 divided by 6.2. And then my second Z is when X is 115. So I have 115 minus 110 over 6.2. Now this one right here, you should notice, is what we did in part A. Okay, 115 minus 110. That's what we did in part A. So I'm not going to redo it again. I'm just going to copy it down. It was 0.8, which was 0.788. Okay, I just copy that one down. There's no point doing it over because you got it already. Now for the other one, 102 minus 110 is going to give us a negative number. We're going to divide that by our standard deviation of 6.2. We get a negative decimal that goes on forever. Remember, we round to the nearest tenth, one place behind the decimal point. So is the 9 going to change the 2 this time?
Yes.
So it'll be negative 1.3. Negative 1.3. So when I go to plug that in there, I got to look at my table. I go to negative 1 down here, and then across to 0.3, and I find 0.097. 0.097. Now, just like we did on part C on number 21, what do we do with those two numbers now?
Right.
Subtract them, because we're finding the difference between them. So we subtract them. When we subtract them, the largest number goes first. So the 0.788, so I take 0.788 minus 0.097, and you get your answer for the area between them. I got my answer. You got one?
Yeah.
That same one you had?
Yep.
Okay. All right. So that part pretty easy?
Yeah.
Yeah? Okay. Now, sometimes with things like this, instead of just asking for the area above or the area below, it may ask for you to write it as a percentage. Hint, last two problems on the quiz. Okay? Ask you to write it as a percentage. So it's the same basic principle that we just did here, okay? You use your little formula, you look at table A, you find the stuff, and then you have this decimal here. How can I change it if I want it as a percent?
Move the decimal 2 places.
So you just move the decimal point 2 places. So this would become
69.1%.
1%. Okay? Now remember, these, you just have like the 3 place decimals. But if you're talking about just finding the z-score, those are rounded to the nearest tenth. 1 place behind the decimal point for your z-score, because you got to have it like that for the table. Percentage, if you're writing as a percent, you'll have 1 place behind the decimal for it too. Okay? So most of them, you're going to have the 1 place, unless it's just finding the area above or area below. Those had how many?
3.
3.
Had 3 places because that was the number from the table. Okay, now let's see. Want to see what others I want to do to make sure I cover everything that's on the quiz. See if you remember anything from last week. All right. Okay, remember in normal distribution, you have your mean, which is the little mu thing, your standard deviation, which is this. Okay, we also had something called the empirical rule. The empirical rule says that all the values fall within three standard deviations of your mean. Because if you remember when we did the little bell curve, and you know, I told you all last week, I don't draw those very well. Anyway, when you had your little curve, you had your little number line across the bottom. I draw that part. Okay, in the middle is your mean, which they use the mu symbol, the lowercase Greek letter. Then going this way, you had 1 standard deviation, 2 standard deviation, 3 standard deviations. Going this way, you had -1 standard deviation, -2 standard deviation, -3 standard deviation. When it is a normal distribution, it says most of the stuff falls between 3 standard deviations from the mean. Most of your data, remember you had the little curve that went up and down, 99.5% approximately is between the -3 and the +3 standard deviations. Okay, now when we had these, we had some problems that were like this. Let's flip the page and look at a couple of problems like that to make sure you have some examples for the quiz. Let's look at page 577. So 577 is a review. You got this picture of all the cars on the highway, traffic, yuck. Okay, Jazaria, you need to get where we can see you or I'm going to kick you out. You've been blocked long enough. So you got your cameras here, okay? I mean, your car's here. I can't see you on camera. You got cars here, all right? So that's page wrong, 577. If you look at 7 and 8, this is talking about like what we did here, okay? It says, and you have a problem like this on the quiz, that's why I'm doing this. This is like one on the quiz. It says, Jenny found that the average amount of time it takes her to drive to work is 23 minutes. So my average is 23 minutes. And with a standard deviation of 4 minutes. So within 4 minutes, it usually takes her 23 minutes to get to work. Okay, so we use those numbers on one of these. Okay, so my center number, my mean, was 23 minutes. Then for each one of these other marks, I'm going to add 4 going this way or subtract 4 going this way because that's my standard deviation. So 1 standard deviation, 23 plus 4 is 27. And then 27 plus 4,
31.
31 plus 4.
35.
Now this way we're going the opposite, so we subtract. So 23 minus 4.
19.
Minus 4.
15.
Minus 4.
11.
So these are our numbers that we have. Okay, so when we're looking at this, okay, when we are looking at this, then it asks at the bottom, the last sentence was, find the percentage of her arrival times between 19 and 27 minutes. So 19 and 27 minutes were just 1 standard deviation either way. Now, we had that empirical rule, which was like, you had 3% in it, right? What is the middle percentage for if it's within 1 standard deviation? See if I remember, it's on like the first page of this section. On the table up at the top right corner. If it's within 1 standard deviation.
68%.
68%. So this is
68.
about 68% of the data is within 4 minutes. Okay? Now, get the idea with those? Pretty easy?
Yeah.
Yeah? Okay, so you have one like that on the quiz. Okay, here's another example of those. A city sheriff department determined that in a 55-mile-per-hour zone, the average driver travels at 55 miles per hour. So your average is 55, what's supposed to be, with a standard deviation of 5 miles per hour over or under. What is the percentage of people who drive outside the limit? Okay, so they're driving outside of the limit. So think about what that means. Okay, so within this, it says outside of the standard deviations. So basically 55 here, so we're just looking at the center part. The center part was what percent?
68.
68%. So if I want to find how much is outside of that 68%, what do I subtract it from?
100%.
100. So 100 minus 68%. So 32% drive outside of that range. Okay? So those are the types of questions that you have on the quiz. Okay? Next type of question, number 9 and 10 on page 577. These are the ones where all you do is read the table, right? Yes? We just read the table. So like on number 9, it says, what's the probability of Z being greater than 1.4? Okay, so I look at my little table for 1.4, right? We find 1. We find 0.4. This is
0.919.
919. Now, this said it was what, though?
Below.
Above.
Above.
All right, greater than means above. So what do I have to do with that? Subtract it from
1.
1. So I have 1 minus that and get 0.081. Now remember, if they wanted that as a percent, I would move my decimal point 2 places to the right and get it as a percent. Okay, just don't forget, if it asks about a percent, you do it. Okay. Okay, on 11 and 12, it's just practicing finding the z-score, which we've done that before. We just did that. We'll do one of those again. And then I'll talk about like the true-false questions on the quiz, because I know you all love true-false questions. So let's look at number 11. It says x is 22. The mean is 24. And the standard deviation was 1.56. Okay, so my formula, remember, for my z-score is x minus the mean divided by the standard deviation. So we have okay, so this is what we got. Everybody with me? Yes?
Yes, ma'am.
All right, so when we're looking at this, we're going to subtract the top, right? Yes? When you subtract the top, you're going to get a what? You get -2, and you're dividing that by 1.56. You get a decimal. Again, big long decimal. We round to what?
Tens place.
Tens place. So it'll be -1.3.
3.
Okay, and that's all it wants. So your answer is simply z equals -1.3. So when it asks you to find the z-score on the quiz, when you're typing the answer on the blank, okay, type in z as well. So z equals the number, okay? Round it to the nearest 10th, type z equals whatever the number is, okay? Let me get your quiz book so I can talk a little bit more about what's on your quiz. All right, so it's quiz number 41 that you're going to be doing, okay? Quiz number 41. Whoops, that's quiz 42, so that's not the right one. That's later this week. All right. Actually, I think it's next week, but anyway. All right, so quiz 41, it has some true-false things. So some of these are things I already said today in class, so let's see if you were listening. It says everybody needs to be where they can answer, so you shouldn't have yourself muted. Everybody should be there where you can be ready to talk, okay? Very good? So, if I say a probability of blank should be used for z-scores greater than 3.9. Now, I didn't talk about that, but you have your table. On your table, if you look at scores that are greater than 3.9, you'll notice all these last ones are all equal to what?
Whole number.
See? They're all equal to?
1.
1, okay? All your little ones up here, when you get to towards negative 3.9, they're all what?
0.
0. So if it's talking about positive 3.9, you'll say they're
1.
1. If it says negative 3.9, you're going to say they're going to be
0.
0. So, again, true-false question. A probability of blank should be used for z-scores greater than 3.9. So you would say what?
0 or 1.
No, I said greater than 3.9. 3.9 is positive 3.9.
Oh, 1.
1.
1.
Okay.
Oh, okay.
Probability of
1.
1. Okay. A blank distribution is a distribution of samples instead of individuals. Well, if it's talking about samples, it's a sampling distribution. That makes sense, right?
Yes, ma'am.
Yeah.
A distribution of samples would be a sampling distribution. Okay? According to the empirical rule, oh, we just talked about that up here. According to the empirical rule, all normal distribution falls within how many standard deviations from the mean?
3.
3. 3 standard deviations from the mean. Okay? The central limit theorem states that the mean of the sample averages is equal to the mean of individual values. True or false? Central limit theorem. Okay, I heard a false. Anybody else have a guess?
Wait, what was the question?
The central limit theorem states that the mean of the sample averages is equal to the mean of individual values.
False.
True or false?
False. True.
Oh,
True.
Okay, everybody hear me?
yes, ma'am.
Okay. What is it?
True.
True.
True. Okay. The mean of the samples is equal to the mean of the individual values. That's central limit theorem. Okay. All right. Now, anecdotal evidence. Does anybody know what an anecdote is?
Antidote is like the it's like basically like medicine, right? Something like that.
The cure.
Yeah, like a cure.
That's
Well,
the only one I know.
another thing.
Like counteracts like a poison or something.
But another type of anecdote is like a little story that represents something.
Oh, yeah.
Okay.
It's
So
poetry.
anecdotal evidence is an isolated case that is cited to support a claim. So basically, it's an instance of showing when it worked. So do you
Oh.
think that's true?
Yes.
Yes. Okay. So you got true, false. You have this to be true. Everybody got that?
Yes, ma'am.
Yeah.
Okay. So you get that, Aurelia? I saw you grinning. You get that? All right. So then you have 2 where you're finding your z-score. So 2 like this where you're just finding your z-score. Remember we said we round that to the nearest 10th.
And
Type in z equals whatever number. Okay, so you got 2 problems like that. You have 1 problem that's like this where you're figuring out the percentage. Okay, so remember you have the table in your book on the very first page of the section at the top of page 565 that shows the percent. So you have 1 like that. Okay, and then you have 2 that are like these over here where we used our table, where we had to take the z-score, get the number from the z-score, and then it wants the answers as a,
percentage.
so you use the z-score, look at the table A, which it's in your book on page 567. It even tells you at the top of the quiz, use table A, page 567. Okay. The last 2, please make sure you put them as
Percent.
percents. So you have 5 true, false, and I already told you how many were true. You have 2 where you're calculating z-score. You have 1 like this where it's dealing with the percentage. And then you have 2 where you're using your z-score, finding the area, and then writing the area as a percent. Okay?
Yes,
Can
ma'am.
you handle that?
Yeah.
Yeah, I hope so. Okay. Now, the quiz will be open in like 10 minutes at 1:45. You need to make sure that you have your book with you before you try to take the quiz, because you got to have your book for the table. Because if you don't have the table, it will mess you up. You need the table. I did not copy and paste the table on the quiz for you because you've got it in your book. So make sure you have your book with you when you go to take that. Okay?
Yes, ma'am.
Understand that?
Yes, ma'am.
Yeah.
Okay. So you have your quiz. It starts at 1:45 is when it will be open. So you have time to kind of get your stuff together. Make sure you got a what if you need it?
Calculator.
Calculator and your book. Okay? Get it done. The better thing to do is do it right now when it's open instead of waiting until like 8 o'clock tonight, because then you forget. It's open till 9, but that doesn't mean you need to wait till 9 to do it. Or after 9 and then email, oh, I forgot my quiz. No. Okay? Do it now. That little brother that I keep seeing head come over. All right. So everybody knows what they need to do?
Yes, ma'am.
Really, quit laughing. Look at her. Look at her. Quit laughing. Stop it. All right. Now, I want y'all to know, y'all made me mad on Friday. Especially some of you who definitely were supposed to come to tutoring and didn't. Because, like, you or your parents specifically asked for it and you still didn't come. Because I went through and I wrote all this stuff up here that I was going to go over with you to help you when you had to retake test 11, and then you didn't come. Look at that. Nobody came. I don't care if it was Friday. The whole point was that you were here, so you had that extra help for your test. You all got like 2.5 weeks left. Some of you all, your grade has gone down greatly here lately, and it's basically not out of not understanding, it's just out of laziness. You haven't turned stuff in, you haven't done quizzes on time, you don't show up for Zoom meetings. Like half of y'all were absent Friday. There's no excuse for that. None. No reason not to be here in Zoom every day we have it. Some of you hiding your camera today when I'd asked you twice already to turn it on and then you're still hiding. No. I should be able to see you on that screen. You should have your book there. You should be following along working. I don't need to see you just sitting, eating, and drinking. I need to see you working. We are almost done. But some of you will be in Algebra 2 again next year if you don't get your act together. So when the rest of your classmates are in geometry, you'll still be with the kids behind you in Algebra 2. Okay? We're beyond playtime now. This is down to the wire. You got to get it done. Okay? Some of you had quizzes that I emailed as attachments like 2 chapters ago that you never turned those in. I'm going to individually be emailing people about stuff that you are missing. Yaneli, put the cup down. I'm going to be emailing people individually about stuff that is missing. You need to make sure you get it done, okay? I will try to have tutoring again with you all, probably on Thursday. It would be right after this class, so no excuse. You'll need to be there. If you need it, you know your grade, you know who you are. You need to come, okay? I'm not being mean. I'm trying to give you all a wake-up call and realize you have to take responsibility for you, okay? I can't do it for you. I'm not at your house and I'm not coming to your house. You've got to do it. But when I make myself available to be here to give you extra tutoring and you're too lazy to type in a code and log in and sit for 30 minutes, I can't do anything for you. No excuse. None. Make sure you have calculator ready. Make sure you have your book ready before you log in to take that quiz. Do not forget, what quiz number is it?
41.
Quiz 41. Okay, but you all, we have no time left. 2 weeks from tomorrow is your final exam. 2 weeks. Let that sink in. 2 weeks from tomorrow is your final exam. Some of you all need to get working and start studying. You need to come to every tutoring I have. You need to take every note you can take so you have something to use for that exam. Okay, but right now, everybody needs to go take quiz what?
41.
41 and do well on it. And be here on time tomorrow at 1 o'clock. Camera ready, ready to work. See y'all tomorrow.